People,
Hello. How goes it? What's up? What's good? Let's talk about Hooke. Mr. Hooke. You guys might have heard of him in biology. He basically coined the term the cell, right? He's the guy that looked, I think it was a piece of cork, looked at a piece of cork with a microscope, said, you know, those look like cells. And he said, that was it. This guy, Hooke, was in the 1600s, same sort of time area as Sir Isaac Newton. Actually fought against Isaac Newton on a lot of his ideas. But Hooke turned out to be pretty much a genius himself too. He did a lot of really cool stuff. But one of the coolest things that he did, I think, in my opinion, since I like physics, was he said, okay, F is equal to negative kx. What does that mean? Force is equal to negative kx. What is k? K is what we call the spring constant. Spring constant. And x is how far the spring was moved from its original position. Let me show you an example real quick. This spring right here is in its resting state, right? It's not moving at all. When I do this, it's being stretched out. That's called stretching it. When I do this, I'm compressing the spring in. Both times, the spring wants to move opposite of what I'm applying, of whatever direction of force I'm applying to it. So I pull it out, it wants to shoot back in. But if I push it in, it wants to shoot back out. Those are the properties of a spring, and that, we'll say, we'll call this just basically displacement. That's Hooke's law right there. Hooke's law. There we go. Hooke's law says that your spring, whenever it's subject to a force, is going to move that certain distance proportionally. It will move proportionally to that distance. Right? So I'm applying a force to this spring. It is moving proportionally to the force that I'm applying to it. It is moving proportionally to the force due to the spring constant. The spring constant, we can also call this stiffness. The stiffness of the spring. The way you solve these problems is sort of similar to F equals ma, but really super easy. I'll give you, for example, I say I stretch the string out using a force of 25 newtons. It stretches out. We'll say it stretches out 10 centimeters past resting, right? So we pick a point and we see how far away it goes from the resting point. We'll call that 10 centimeters. What is the spring constant? How stiff is the spring? Very simply, we put 25 is equal to negative k, and we'll make this 0.1. So you divide by 0.1, divide by 0.1. Our negative k is then equal to 250 newtons per meter. Where does this negative come into? This negative is essentially saying that whatever action you do to the spring will do the opposite. The negative, the way I like to think of it and the way I expect you guys to sort of write it is this. If you're stretching a spring out, it's positive, okay? You'll have a positive answer. If you're compressing the string, you'll have a negative answer. I always think of like moving it away is positive and then pushing it inwards is negative. That's just the way I like to think about it. If that makes it easy for you guys, that should be easy. But try this worksheet that I gave you guys. You should be able to do it. No problem.